So in this video, we're going to dig back to finding the slope between 2 points. So it's possible that as we go through this video, you may need to go back there to review how to find the slope between 2 points. But we're going to work on point slope form. And again, as mathematicians, we're not too original. That means I need a point and I need a slope to write the equation. We're going to actually learn how to write an equation of a line using 2 points, and we're going to learn about fitting the equation of a line to a data set, which is not going to be covered in most algebra courses, so if that's not in your overview, you can omit that last part of the video. So to use point slope to write an equation of a line, I need a slope and a point, and so the actual point slope equation is this bottom portion. I would suggest writing this on a post-it, writing this something by your computer or a formula sheet, however you can keep this directly in front of you as we work. So in order to put something in point slope, you're going to leave this y and this x as a variable. You're not going to replace those with anything. The m is going to be replaced with your slope, and x1 and y1 are going to be replaced with a point. Well, how do I know which point? It's the first one, x1, first one. So if we want to write an equation of a line going through 5, 2 with a slope of -1/3, I have the slope and I have a point, so I want to use the point slope equation. Here's the point slope equation. I'm only replacing what's in red, blue, and green in the equation and nothing else. So my point is 5, 2, with 5 as the x value and 2 is the y value. So I'm going to plug those in. My slope, they told me it's -1/3, so I plug it in. I'm done. That's all I have to do. I can distribute the 1/3 through if I want to, so 5 times 1/3 would be 5/3, but you don't have to per se. So this is the main way we find things in point slope. I can solve it for y to put it in slope intercept. So I can go from point slope, solve it for y, and I'm in slope intercept. Why do we do that? Well, because it's often easier to graph this if I know slope intercept. Is every homework question going to ask you to do this? No. Read the question carefully. It might be done here at this step, or it might say go ahead and do it in slope intercept form, which means you've got to solve for y. To write the equation of a line using 2 points, I'm going to find the slope, then I'm going to plug it in point slope, okay? Then I'm going to deal with part A and point B, so just hold with me. The first point is x1, y1. The second point is x2, y2. So I'm going to take that formula. Remember, my y's go in the numerator, my x's go in the denominator, and so I get a slope of -1/3. Once you have a slope and a point, you can put it into point slope. How do I know which point to use? Well, mathematically, I can tell you either one. For force of habit, please use the first point. Always use the first point. It's not going to lead you astray. This is the answer in point slope, right here, done. Now, part A says I want it in slope intercept, which means solve for y. So I have to distribute the 1/3 through, then I have to add the 5 to both sides, and there it is in slope intercept. For standard form, I need x and y on the same side, so I need to add that 1/3 x over to the other side. But because I have fractions that are all a denominator of 3, if I multiply everyone times 3, y times 3 is 3y. 1/3 times 3 is -1. 7/3 times 3 is just 17. Then I can bring the x over, and that is how you get to standard form. So this is manipulating the equations, not actually doing arithmetic. We're just manipulating the location of the variable. There's a very good chance you may need to rewind the video and watch this process again. It's going to take time to click. So watch this as many times as you need, or message me if you need additional help. This is the part where if you're not covering this week, you can definitely stop the video here and just let that beginning part soak in. If I'm given a data set and it's linear, I can use any 2 points within that data set to be able to find the equation of my line. So each one of these values is considered a point within the data set. I can take the slope between any 2 points. So here I chose 6185 and 4645, and that gives me a slope of 385. Now that I have a slope and a list of points, I can plug into point slope. And this is the line that fits the data in the model. I can take this further and distribute that 385 through, add 4645 over, and I have it in Slopeintercept. I can plug in 9 to check my work. If I plug in 9, I should get 7,050 out. I don't. I don't get exactly that, but I get close to it. And that's what's different about fitting an equation of a line that models data, is it might not be exactly on the line, but we want it to be close to the line. So because 6955 is close to 7,050, I can say, okay, we're a little off, but it still kind of fits the data.